Hello everyone, welcome to Coders Camp. So we are at the 20th day of April LeetCode Challenge, and the problem we are going to cover is N-ary Tree Preorder Traversal. So what is an N-ary tree? Unlike binary tree, it has any number of children, because in binary tree we will be having only two children, left and right, but here you can have any number of children, which is actually N-ary tree. So now the input given here is a root of an N-ary tree, and we have to return the preorder traversal of the given tree. So now if you observe how they have implemented the N-ary tree, the children of a root node or any node is represented as a list and the name is children. That has to be noted. So now let's understand this problem with an example. So here is our given N-ary tree. So generally the pre-order traversal would go visiting first the root node and then the left and right children in a binary tree. Here it first visits the root node and then followed by the children starting from the leftmost to rightmost child. So now here the pre-order traversal gonna start at root node 1. So first our list gonna add 1 and then moving on to its children 2, 3 and 4. So now we are going to add 2. So before moving to its next child 3, 2 has its own children. So we have to visit its children first and then come back to the next node. So if you visit the children, the order is going to be 5 and 6. So now its children are done. They don't have further children left. So moving on to the next child of 1, which is 3. 3 doesn't have any children, so moving on to 4, we are going to add 4 and 4 also don't have any children. So this is going to be the pre-order traversal of the given tree. So how are we going to approach this? It is a straightforward DFS solution because any pre-order traversal is a depth first search technique. So you can straight away use a iterative DFS or a recursive DFS to solve this problem. So here in this video we are going to see how iterative DFS is going to work using stack and go for our implementation. So let's dive in. So if it is an iterative DFS, always stack comes for help. So if you are familiar with how DFS works, so you can skip this part. Otherwise, this is where you're going to learn. So now we are going to start from our root node. So we are going to push that node first to our stack. So we are going to push a 1 to our stack. So once we pushed 1 to our stack, we are going to iterate our stack till our stack gets empty. So going forward, we are going to add elements and remove elements till the stack gets completely empty. So now we are going to pop what is the root element or what is the element present in the stack. The first element is going to be 1. We are going to add that to our answer or list. Why? Because we always visit the root node first and then move forward to its children. So once we have added the value to our list, we are going to further add its children in an order reverse to the left, that is from right to left. Why? Because stack always takes the last element first. So if we want the elements to be from the order 2, 3 and 4, that is from left to right, then we have to put that element into stack from right to left so that 2 sits in the top of the stack. And when we pop the element from the stack, the top element we get will be the leftmost children of the root node. So hope you're understanding. So I'm going to add my values in the reverse order so that my stack is going to have 4, 3 and 2 now. So it's time to pop the element from the stack. So we are going to pop 2 first and add that to our list. So as per the pre-order traversal, the first children is being added. So for now we have popped 1 and 2 from our stack. So now it's time to explore 2's children. We are going to check whether 2 has any children because as per pre-order we have to visit the children and then move on to the right node or the sibling node. So now we are exploring its children. We have 5 and 6. So again it's time to put the nodes in reverse order because if we are traversing in pre-order, after 2 we have to get 5 and 6, that is from left to right. So in this case we want our 5 to be popped next. So we are going to put the elements in reverse order. So let's put the element from right to left. The children are going to be 6 first pushed into stack and then 5. So now our top element is now 5. So we are going to pop 5 from the stack. So we are going to check whether 5 has any children. No, 5 has any children. So we don't have anything left to add to our stack. So simply we are going to add that to our list. So now we have traversed 5. Now the top element is 6. We are popping 6 now and check whether 6 has any children. No, 6 doesn't have any children. So we are going to add that to our list. So now our top element is 3. We are going to pop that from our stack and check for children. No children, so add that to our list. And finally, our top element is now at 4. We are going to check whether children, no children. So we are going to add that to our list again. So once we added, we are going to pop it. So finally, our stack is empty. So we don't have any other nodes left to be traversed. So this is going to be the actual output we wanted. That is pre-order traversal of the given tree. So simple, we are going to push the elements in stack from right to left so that when we pop, the top element will be the leftmost element. And we are going to explore its children first, then moving on to the sibling node or the adjacent node to the given root node. So hope you're understanding this solution. So this actually works in big O of n time as we are going to iterate through the number of nodes given only once. And the memory is big O of n again because we are going to use the stack for our space. So yes, hope you're getting the solution. Let's go for implementation now. So yes, for DFS, we are going to declare our stack first. And I'm going to declare my list for output. It is going to hold the values of the nodes. So finally, this is actually our output we are going to return. So in between, first we are going to add the root node to our stack. So once we pushed, we are going to iterate till our stack is empty. So every time we are going to pop the node from our stack and add pop nodes value to our list. So yes, once it is added, it's time to check for its children. So here they have implemented its children in the form of array list. So we are going to get the size of that array list of its children so that we get to know how many children it has. So we are going to put that in reverse order. So our iterator I is going to start from the last node of current. So current dot children dot size will have the rightmost child. So if they have any children, then we are going to push that to our stack in that order. So yes, once the iteration is done, our list will be having the pre-order traversal values of the nodes given. So let's run and try. Yes, so let's submit. Okay, we should check a basic condition that if our list is empty, then we have to return null. So we are going to check whether if our given tree is null, then return an empty list as our output. So let's submit now. Okay. So yes, let's submit. Yes, the solution is accepted and runs in 2 milliseconds. So thanks for watching the video. If you like the video, hit like, subscribe and let me know in comments. Thank you.